Let's talk about another type of denial of service attack. This one is called a Smurf attack. I can't remember off the top of my head why it's called a Smurf attack. You can look it up if you're really interested. The Smurf attack is a non-operating system specific attack that uses a network to amplify its effect on the victim. Now I'll show you how that works here in a moment. It's based on the fact that you send a ping reply request. This is also known as a echo request to a network broadcast address. Now I'll show you what this looks like here in a moment. Using the victim's address as the source. So for using here, you could put in here spoofing. So you're crafting a packet, sending it to the broadcast address of a network, and it's an echo request packet, and you use the source IP number. You can put that in there. The spoofed source address here is actually the IP address of the victim. Now, in response to this echo request, the network will flood the victim with ICUP ping, the Internet Control Message Protocol, ICUP ping replies. The idea is to saturate the Internet connection to the victim with bogus traffic, and that would delay or prevent legitimate traffic from reaching its destination. This is where the denial of service comes in. So we have a graphic here on the next slide. So down here you have the attacker. And up here you have the victim. So the attacker crafts a packet and sends it to a network, and we usually call these networks Smurf amplifier networks. And these networks allow packets to be addressed to the broadcast address for the network. Notice the last octet has .255 in it. So this is going to be the broadcast address for this network. And so you've got a ICUP echo request being sent to a entire network of computers, and they're going to reply. And what we've done here is we've spoofed the IP address of the victim. So when the replies come, they're actually all directed to the IP address of the victim. So you can, destination source, here you go. So they're all going to be sent to, in this case, 172.18.1.2, which happens to be the IP address of the victim. And the idea here is to overwhelm the WAN link. The WAN link, WAN is the wide area network. So the WAN link is the connection to ISP is the WAN link. And your connection to the internet is not for lack of a better word, a pipe of unlimited size. So if the attacker can generate enough traffic of any type, your bandwidth could be consumed, and in this case, or in that case, a legitimate user would not be able to access your server. And these are typically web servers that are the victims. And therefore, there's your denial of service when a legitimate user can't get to the victim site simply because there's no bandwidth available for the packet to get through. So this is how a Smurf attack works. What can you do about this? You should make sure that on your network that you configure your router to drop all ICOMP messages with the destination of an internal broadcast or multicast address. I'm of the opinion you should configure your routers to drop all ICOMP messages anyway. The reason for this is to prevent your network from being a Smurf amplifier. This is not going to keep you from being attacked, but it will prevent your network from being a Smurf amplifier. You should also configure your internal host to ignore echo requests sent to their broadcast address. You can check, I haven't checked recently, but last time I did check, this site was still up. I'm having problems with my internet connection here at home tonight, so I can't really verify this. But here's a website that you can check to see if your network is, well, this one and this one both, if your network is properly configured such that it is not a Smurf amplifier. So these are all mechanisms set up to prevent your network from being a Smurf amplifier. If you're being attacked in this case, about the only thing you can do is, if you note the packets coming in and note where they're coming from, you could potentially call your internet service provider on the phone and say, would you make changes to your routers such that you would drop the packets from this network. So, but that's what you do if you're actually under attack, is you try to start filtering the packets from that network, the Smurf amplifier network. So Smurf is one of those attacks where you don't have to have a vulnerability here. And by vulnerability I mean you don't have to have a coding error, some sort of programming error in your operating system or any of your applications. The Smurf attack works because of the way the internet was designed, particularly the ICOMP protocol, whereby unless you specifically turn the behavior off or you block it, if one computer sends a ping or an echo request to another computer, that computer will respond with a echo reply. Now, again, you can turn this off, and I really recommend that you do at your router. You should block ping requests coming in from the internet for a number of reasons. One of the reasons is that can be used to kind of map your network from the outside. Any internal machine that replies to a ping request is obviously up and running. So I recommend that you actually block these coming in to your router from the internet, and this is any kind of ping request, not just these broadcasts or the ping requests that have been directed at the broadcast address. So think about this for a little while. It's one of those things that has a certain beauty to it. They are effective. And the main reason they're effective is some network administrators haven't properly configured their networks, and therefore their networks can become Smurf amplifiers. And if you go to this site here, you can get a list of most popular Smurf amplifiers. And since these networks have not been configured properly, it's possible for an attacker to, with one packet, elicit many packet response directed at the spoofed IP address of the victim. So again, this requires no vulnerability in the operating system of the victim or any applications running on the victim. We're just the attacker is utilizing the way the internet works and the way the protocols were actually designed.